So now let's see the summary of your module 1. So your first section of your module 1 was your power supplies, right? So under power supply you had the block diagram of your power supply. So what was your block diagram of your power supply? High voltage AC signal was given to the first stage, that is your step down transformer, right? Transformer. The output was your low voltage AC, which was given to the next block, that is your rectifier. Okay, the output of the rectifier was unsmoothed DC, which was given to your reservoir or smooth filter. Okay, the output of your smooth filter was your smooth DC, which was given to your next block or the last block, that was your voltage regulator. Output of the voltage regulator was regulated DC output. Regulated DC. Okay, so this was your major block diagram of your power supply. So under this section you had the important topics were your half wave rectifier. First one, half wave rectifier. Okay, so what was your diagram for your half wave rectifier? You used only a single diode, right? You had your 240 volt supply which was given to your step down transformer. So here you had got 12 volt which was given to a single diode to which you had connected your RL. Okay, so this was your half wave rectifier. So what was your output? So suppose this input was your sinusoidal signal V in. Your diode conducted only during one half cycle, that is during only positive half cycle. So what was your input? Only during positive half cycle you got the output. Okay, so this is your V out. Okay, now the second diagram was your full wave rectifier, biphase, right? So full wave rectifier. So under full wave rectifier you used two diodes. Okay, 240 volt, that is center tapped. Okay, diode D1 and diode D2. Then it was center tapped and you have connected it to the RL. Okay, so this was your V out. Here also this was your V out. Now what was your diagram for your full wave rectifier? You had the output in both the half cycles. Okay, so this was your output of your full wave rectifier. Okay, now what was the voltage here? It is 12 volt. Here also it was equal to 12 volt. Okay, the next circuit was your bridge rectifier. So wherein you have used your bridge. Okay, so it was 240 volt. Center tap was eliminated. You have given to the bridge circuit. Okay, so what was your positive, negative, positive, negative, positive, negative, positive, negative. Okay, if I take this as A, B, so here was your inputs. You have taken the output across this RL, right? So D1 opposite are the conducting diodes, D3 and D4. Here it was equal to 12 volt. Okay, now the output is same as that of, the output of this is same as the bridge rectifier is same as that of your full wave rectifier. Okay, so the next circuit diagram was your smooth filter. So if I add a capacitor to all these three circuits, it becomes the diagram of your what? Capacitor or a smooth filter. So what is your output? This will be your corresponding output. Okay, charging and discharging. So this is your corresponding output. Ripple with DC with small ripples. Okay, Now the last one was your voltage regulator. Do you remember the voltage regulator circuit, which consists of a Zener diode? So voltage regulator. So your smooth DC was given to your voltage regulator, which consisted of input resistor RS with a Zener diode. Okay. So what was the input? Unregulated DC, right? And here you had an RL. This was your VZ. V0 was is equal to VZ. So what was your output? Corresponding output, you got a constant voltage. That was your V out. Okay. The next topic was your voltage doubler. So if you want to increase the voltage, you have gone for your voltage doubler. So what was your voltage doubler? In the half wave rectifier, if you add one more diode, that was the circuit of your voltage doubler, right? So here you had positive, negative. You are going to add one more diode to it. So your negative, positive, and what you are going to add to the capacitor. So this was your RL output, V out. Okay. So diode D1, diode D2. D1 will charge capacitor C1, D2 will charge capacitor C2. So here it is positive, negative, it is positive. So here it will be negative, positive. Okay. So what will be your output of voltage doubler? V in, if the maximum voltage is Vm, V out will be equal to 2 times of Vm. That was your voltage doubler. The next topic was your voltage tripler, right? Voltage tripler. So what was your diagram for your voltage tripler? You are going to increase the number of capacitor and the diode. So you had your input 240 volt, which was given to your first capacitor C1. From this C1 you are going to give to 3 different diodes, right? Now from here you have capacitor C2, then you had your third diode D3, to which you are connecting your third capacitor C3. So C1, C2, C3, D1, D2, D3. So D1 will charge C1, so it is positive, negative. Here D2 will charge C2, negative, so it is positive, negative. D3 will charge C3, positive, negative. Okay. Now what will be your output? If maximum voltage of Vin is equal to Vm, your V out will be equal to 3 times of Vm. Okay. So by this your first section is over. Your second section was your amplifiers. So under amplifiers, what are the different subheadings you have studied? First you are going to study the different types. You had studied the different types, right? So under different types, how many different types you have studied? You have studied 8 different types. So what is your first type? AC coupled. Second one is your DC coupled. Third one is your large signal amplifier. Fourth one is your small signal, right? What was your fifth one? Audio frequency amplifier. What was your sixth one? Radio frequency amplifier, RF. Seventh one, wideband amplifier. And what was your last one? Low noise amplifier. 8 different types of amplifier. Okay. After types you had certain definitions. What is gain? So gain is always equivalent to output divided by input. Under the gain you have studied 3 different types. One is your voltage gain, current gain and power gain. Voltage gain is equal to V out divided by V in. Current gain is equal to I out divided by I in. Power gain is equal to what? Power out divided by output power divided by, I can write output power divided by input power. You also have one more formula, power is equal to V into I. So power gain is equal to product of your voltage gain and your current gain. Then you had the next formula, input and output resistance, right? So what was your input and output resistance? So input resistance R in is equal to input voltage divided by input current. Similarly, output resistance R out is equal to output voltage, open circuit output voltage divided by short circuit output current, I out. Okay. Now next one, you had frequency and bandwidth, frequency response and bandwidth. So what was your frequency response looking like? You had your frequency response AB. This is your frequency gain in dB, right? Gain in dB. At low frequency and high frequency, your gain decreased, right? Mid frequency, mid band, it was stable. Okay. So wherever you have minus 3 dB, that is nothing but equal to 0.707 AV. What you had two frequencies, lower cutoff frequency and upper cutoff frequency. Therefore, the bandwidth will be equal to upper cutoff frequency minus lower cutoff frequency. That was your frequency and bandwidth. Next, you had phase shift. So what was your phase shift? Output voltage with respect to the input, you have got 180-degree phase shift. Okay. The next important topic which you have studied is a negative feedback for amplifiers. So negative feedback. So what was your diagram for your negative feedback? Voltage series, right? So this is your gain AV, this is your beta feedback network. So this was your V out. So it was parallel connection in the output, series connection in the input, right? So this was your voltage VF, this is your VS and this is your V in. So negative feedback means here it is plus, here it is minus. Therefore V in is equal to VS minus VF. Okay. So what was your gain formula? AV is equal to your overall gain G is equal to AV divided by 1 plus beta into AV. So this was your gain formula for your negative feedback. Okay. The last topic what you have studied in the second section is multi-stage amplifier. So what was your multi-stage amplifier? Two-stage amplifier. Do you remember the circuit? Okay. So first draw the diagram of an CE amplifier. RE, CE, RC, R1, R2. This will go to your VCC. You have input coupling capacitor, output coupling capacitor, CC. So this will be your V in, right? Output of the first stage will be connected to the base of your second stage. So repeat the same diagram of RC coupled amplifier in the second stage. RE, CE, again you have R1, R2, RC, same VCC will be connected. Okay. This will be your output, V out. Let me take this as C2. So these are the important topics in the second section, that is in the amplifier. Moving on to the third section. What was your third section? Third section was equal to your op-amp. Okay. So under op-amp you have studied what are the different types you have studied. So op-amp. So under op-amp you have started off with different op-amp parameters. So what was your different op-amp parameters? Open loop gain, AV, open loop. Next one is AVCL, closed loop. Then you had input resistance and output resistance. Okay, input resistance, output resistance. Then input offset voltage. Then you had full power bandwidth, and the last one was your slew rate. So these are the important topics which you have studied. The next was your characteristics. So based on these parameters you had certain characteristics. So what was your characteristics? So first one, your voltage gain was high, right? So let me write voltage gain was very high. That is Ideal case it was infinity, so it is in the practical it is in the range of 10 raised to 5. Second one, your output resistance was very low. Practical case was 20 ohm, whereas your input resistance was very high. Your value was equal to 100 mega ohm. Okay. Next, bandwidth should be as wide as possible. What was your value? 2 megahertz. Slew rate should be very high. Very high. Practical is 10 volt per microsecond. And the last one was your input offset. Offset which should be very less. It is less than 5 millivolt. Okay. These are the different characteristics. Okay. After characteristics, you have gone for your op-amp circuit. So what was your, not op-amp circuit, configurations. So you have studied 3 configurations. One is inverting amplifier. Second one is your non-inverting amplifier. And the third one is your differential amplifier. Okay, differential amplifier. So if the input is given across the inverting, then it is called as inverting amplifier. So what was your circuit diagram of your inverting amplifier? Okay, so non-inverting terminal will be grounded. So input was applied across your inverting terminal. So RF, R1 or Rin. This was your V out. Okay, inverting. Now what about your non-inverting? The input is applied across your non-inverting terminal. So here you had your input applied across your V in. So your non-inverting terminal was grounded. Okay, R1, RF. This was your V out. Now the last one was your differential amplifier. So you had differential amplifier, you had input applied in both the terminals, plus, minus, right? So here V1 was applied across your non-inverting terminal, which is equal to RF, R1, so V1, and V2 was applied across your inverting terminal. Okay, RF and V2. Okay, so what was your gain in this case? Gain was equal to minus RF divided by R1, whereas in the case of non-inverting it was 1 plus RF divided by R1, and from the case of differential amplifier, what was your let me take it as output voltage, which is equal to RF divided by R1 into V1 minus V2. Since, okay, so this was your different formulas, right? Now last one was your different op-amp circuits. So op-amp circuits you studied 5 different op-amp circuits. First one was your voltage follower. Second one was your integrator. Third one was your differentiator. Right? And the fourth one was your comparator. And the last one was your summing amplifier. Summing amplifier. So what was your voltage follower? If the input is directly fed back, so positive, minus, so input was given to your non-inverting terminal and the negative terminal was directly fed back. So V out. Here the gain AV is equal to 1. Now what about your integrator? Plus, minus. Your feedback resistor was replaced by your capacitor. Okay. So non-inverting terminal is grounded. So input is applied across your inverting terminal. Only you are going to replace your RF by your capacitor. So this is CF and this is your RN. V out. Now what is your differentiator? Opposite of your what? Integrator. So plus, minus, just you relocate your CF and RN. So non-inverting terminal will be grounded. Vin will be applied across your inverting terminal. Instead of resistor, now the input will be C in and feedback will be RF. That is the difference between your differentiator and integrator. Second one is your comparator, or it is a differential amplifier where you will be giving V2 both the inputs V1. It will be switching back plus VSAT to minus VSAT, V out. And the last one is your summing amplifier, which sums the both the inputs given. So non-inverting terminal will be grounded. Now the inverting terminal I am giving two inputs, right? So this is your V1, V2, R1, R2, and this is your feedback. So sum RF. These are the different circuits which you have studied in your op-amp. And the last one was your oscillator. So in the case of oscillator, what are the different circuits you have studied? You have started off with your positive feedback, opposite to that of your negative feedback, right? Positive feedback. So under positive feedback, if I take voltage series AV, beta, then what was your diagram? V0, right? Parallel connection. Here it is voltage series. The only difference is here your VF is plus. This is your VS. This is your VI, right? So VI will be equal to VS plus VF. That is the only difference. Gain is equal to, the overall gain is equal to AV divided by 1 minus beta into AV. Okay. The next next one was your condition for oscillation, right? Condition for oscillation, very very important. The angle beta should be equal to 0 degree or 360 degree. Okay. And your loop gain, magnitude of your loop gain should be always equal to 1. This is also called by another name, that is called as Barcode Criteria. The third, you are studying two different networks. That is your ladder network based on your components, that is resistor and capacitor. Two networks, one is your ladder network and the second one is your Wien bridge oscillator. Okay. So what was your ladder network? Ladder network RC phase shift. So give the diagram of your RC coupled amplifier, RECE. Okay. RC, voltage divider across your input, R1, R2, coupling capacitor across your input, across your output you had your coupling capacitor. Now across the output you're not going to apply any input, right? So the feedback is going to be a ladder of 3 capacitor and resistor. So this is going to be a RCCR. So this is your response. So what is your frequency value here? F is equal to 1 by 2 pi RC into root 6. What should be your magnitude of AV? Should be greater than or equal to 29. Okay. Second one is was your Wien bridge oscillator. So in the case of Wien bridge oscillator, you had, what is the connection? A series connection of your resistor and capacitor R1 C1. Similarly, you had a parallel connection of your resistor and capacitor, right? R2 C2. If I take this as A, B, so C, again you had two series resistor R3 and R4. R3, R4. So this is your D. AB was your input, right, of your bridge, and your CD was your output of your feedback network. Okay. So what is your frequency of oscillation in the case of Wien bridge oscillator? If R is equal to C, then if both the R are equal and if both the capacitor are equal, then it was equal to 1 by 2 pi RC. What was your magnitude of beta? Should be greater than or equal to 3. Okay. The next network what you have studied is called as multivibrator. So multivibrator you had studied single stage stable. Single stage stable multivibrator. So you have designed using op-amp, right? So do you remember the circuit which was positive feedback? So here you had non-inverting terminal given to the positive feedback. This was your V out. Now across the inverting terminal you had your capacitor, right? You had your capacitor and your resistor circuit, RF. Okay. So now as the what will be your output? This was your output. Whenever it is VSAT plus VSAT, what will happen? Your capacitor will charge and it switches between two values, that is VUT, upper triggering point, and VLT. What is your upper triggering point? Which is equal to R2 divided by R1 plus R2 into Vout. So R2 divided by R1 plus R2 into V out is nothing but plus Vsat, first condition. Now VLT, lower triggering point, is equal to R2 divided by R1 plus R2 into minus Vsat. Okay. And the last topic was your crystal oscillator. So in the case of crystal oscillator, you had used one crystal, quartz crystal, right? This is the special which will determine the frequency. So it worked under fundamental frequency and overtone frequency. Fundamental mode and overtone mode, high frequency as well as low frequency. So what is the value for your fundamental mode? 100K to 20 mega. Overtone was 20 mega to 100 mega. Okay. So these are the different circuits and waveforms used in the module 1. Op amp. Next you had your amplifier and your full wave rectifier.